Alright, this is gonna be a quick fan noise review. Quick because I got all my hardware now for my new system and I want to build that rig. Yeah, so this is the EVGA GeForce GTX 980 Ti hybrid. That's the 12 centimeter radiator plus fan there. I don't know what kind of fan it is. So this right now I'm controlling it with the speed fan, nice tool, and I only have the pulse width modulation, not the RPM. So it's at the fan is at 30% and the water pump is at 60%. I don't want to go below 60 for it, or it makes some weird noise. So 60% is a healthy RPM for the water pump. Yeah, and I got everything I need. Artificial lighting, daylight fluorescent lamp. I got my movie clapper for sound sync. And yeah, artificial lighting. There it is. And say hello to Mike. And most importantly, as the pro does, little stickers as markers on the ground, so that I know exactly where my tripod has been sitting, so that sound recording distance is right. So let me place it right where it was before. Yeah, those little things, if you want to make sure the test conditions are identical. So I will give a sound demo first, and after that I will install the Nidec gentle Typhoon fan with a high static pressure, and then see what results we get. I will use the Heaven benchmark and let that run and get some rough numbers. It's not super accurate, but just that I get an impression of GPU temperature. And for that I will, just for this set, EVGA Precision X, temperature target very high, power target 100, but just so on the other hand, no, temperature target is on 67 degrees Celsius, so that shouldn't be a problem. It won't reach that anyway. So, okay, automatic speed fan to manual. And now what I will do, I'll do 0% RPM, and every time you hear me use a key, I will go 5% higher. So as you see, the fan is now offline. And I will quickly demonstrate the pump noise from 60% to 100, in case you can hear it. 60 now, and when you hear the key, it's going to 100. Hear that? That's the pump at 100%. But won't be a problem when the fan is on anyway. Okay, so back to 60, and now the fan. This is 0%. Every key is 5 more. 5. 10, 20, 50 now. $75. This is maximum RPM now for the EVGA cooler or the fan. And for the benchmark, I will let it run at 100%. Again, we will see both fans at their maximum noise level and see how much cooling they can do, and just so that we have a proper measurement. So I mustn't use my fan speed curve for that, so that it doesn't get too confusing. So I will leave this at 100%, and now the water pump is at 100% too. And now I will start the Heaven benchmark and report the GPU temperature to you. Right now it is 25 degrees Celsius. Okay, let's just see. It's a moderate, it's not full screen, I have a benchmark, so that I can still monitor stuff here, but it's quite demanding. Okay, let's see. 26, 27, 29, 31, 32. Card is dynamically overclocking, is at 1366 megahertz at 1.2 volts. It's at 35 degrees Celsius. 36, 35 again. Okay, you know what? This might not suffice. Let's do full screen. Let's go all the way for power. Okay, let's see. Native resolution. Everything ultra, extreme, DirectX, 8 times anti-aliasing. So I'm not going to use benchmark mode because it ends at some point. I'll just leave it running, and nicely they have in benchmark reports the GPU temperatures to me. But what I actually should maybe do, because this is cooling so well, I mean it's not going over 30 right now. I used to have a fan curve that would kick in later. So I will set the fan to 50%. And the pump to, let's see, how are we making it? The pump is noisier than the fan now. Let's give this a test run at, fan at 50% and pump at 60. Oh, let's both do at 60. Yeah, 60, and having benchmark full screen. All right, so I don't know, why is it still so low? Something's not quite right here. 15 frames per second? Oh, it's not the benchmark. Huh? Let's try the benchmark. Yeah, this is just great. So something something here isn't going the way it should, because the GPU is not getting temperature. Okay, let's try no anti-aliasing. That usually burdens the CPU more. Let's see what happens. Okay, got an insane frame rate. $38, $39, going back to 38. Okay, that's the fan at 30% now. Give this some temperature. Okay. $43, yeah. It's climbing. But I had some weirdness anyway lately where I compared to my old Heaven benchmarks with the same settings right when I got my graphics card, and they were much higher than they are now. So I'm not sure what's happening with the system there. Okay, so we got 47% now in Heaven benchmark. 48, so 50. Okay, so what I've done now is frozen the camera at a part of the Heaven benchmark that is particularly difficult, the dragon statue. That should burden the CPU properly. But the temperature is climbing really slowly, and so this is the usual operation. I used the fan curve, and it kept the fan at lowest RPM, and then after a while when the heat had built up, it would suddenly speed up. So we are at 55, and I usually set it so it shouldn't get over 60, because liquid cooling 60 degrees Celsius is a good guideline, although the GPU will always be hotter than what the liquid has. Okay, so now we have 57. This is good. Now I will leave the pump at 60 and fan at... Yeah, so this is what I will do with both fans. 30 and 60, my regular. And once it hits 60 degrees, I will immediately put the fan to 100, but leave the pump at 60% to see what the fan can do regardless of the pump. Okay, almost 60. Now the graphics card, okay. At 60, graphics card own fan is revving up to at 50%. And now 59 degrees Celsius. So this is the noise, remember 58, the noise level of the EVGA fan to bring it back down from 60 degrees Celsius with the pump at 60%. 57 degrees. Because if I set the pump to 100%, it would contribute way too much to the results. 57, 56, seems to be staying at 56. Okay, so 56 after a short while, and now I will 55, and now the pump to 100%. Yeah, it's going back to, it's fluctuating between 55 and 56, so that's a good result. GPU fan is 47%. Okay, so now fan 100 and pump 60. Now I'll set the pump to 100, so you can see, learn the difference. Pump is at 100, 54, 55, 54, 55, 54. Oh, not making that much of a difference. There you see water cooling is quite stable, so the pump is running a little bit slower. Not that extreme of a difference. So it's staying at 54, so that's a good guideline. So set up 54 degrees Celsius, both at 100%. Fan speed is at 45%, and this is all with the Heaven benchmark looking at the dragon all the time, which is freaking complex. Okay, so now I will install the Nidec Gentle Typhoon, and then we have a direct comparison to that. And I will make that quick. I'll probably do it the other way around, a direct comparison from this footage right to the same state, jumping to the comparable state with the Gentle Typhoon. Yeah, it's still at 54. So then I'll be back in the moment with the Gentle Typhoon. And I am back, and I decided to do the direct comparison in editing later, so we can jump right in. So that's a Nidec Gentle Typhoon. As you see, it revs a lot slower at a certain throttle percentage. So that could mean that it's quicker or not so quick. I noticed the EVGA fan has 0.2 amps specified, while the Gentle Typhoon is only 0.13 amps. So it's taking less energy at full speed. Okay, so we got everything set up. Fan at 30%, pump at 60. Now I'm gonna run the Heaven benchmark and stop at the Dragon. I'll do that right away. Right. Let's see. There's the Dragon. We have it 43%, and I will get ready as before. Only the fan at 100%. So as you can understand right now, the fan it's not even putting out any air at this rev. Okay, so 48 degrees, we are climbing up to 60 quickly, and then the fan at full speed, and then later the pump. So the fan got at 55 to 56 the EVGA, and then with the pump to 54. GPU, the cooling the RAM onboard fan is revving up. 53 degrees, we are close to 60. And I will do the stepped sounds in the end at the different speeds. Okay, 56, we are close. I'll make a summary in the end and give you a comparison of that again. It's 57 degrees. 58. 59, and when 60 I will rev up to 100% fan, 60% pump. $59, 58, quite warm. 57, 56, 55. Seems more pleasant in sound. Throughput is not particularly higher. 55 degrees. 54. Yeah, 54, 55, it's fluctuating around that now. So if it stays at 54, 53, 54, okay, so minimal difference. So the cooling performance is probably about the same now, a little bit better apparently. And now I will kick in the pump at 100%. We have 53 degrees. Pump is at 100, 52, 53, 52. Staying at 52, so that would be 2 degrees lower than with the EVGA. So we have from 54 to 52 with a sound that is quite pleasant. Now it's scratching on the 51, so 2.5 degrees lower, I would say. And so let's quit this and okay, now it's really dropping. So now I will give you again pump to 60, and now the sound levels. Again, with every key press you have one step, so we have 0%. And you notice how the fan keeps revving, nice ball bearing, low friction, high momentum. It keeps spinning for quite a while. And I guess that contributes to the low noise too, because there aren't much forces on the rotor. Okay, so 0% now, 5, 10, 15, 20, 25, it's really 30, oh, 35. I would say 40 is a safe start noise. So 40, 50 now, 55, 75 now, 100. There's a scratchy noise I notice. That is quite distinct. We'll have to do direct comparison to see how the noise profiles differ, but the fan definitely has a distinct noise characteristic. Yeah. Okay, so then we will go to a summary. Let's see direct difference.